Welcome back. In this part, we are going to take a look at the switch case statement, okay, or the switch case instructions. Okay, so switch case structures can be very complicated when viewed in assembly language. So we will examine a few examples. Okay, so first, keep in mind that in C there are several keywords that are commonly used in a switch statement. Okay, so here's a recap. Okay, so we have the switch. Okay, so this keyword tests the argument, okay, and it starts at the switch structure. Okay, and another one is the case. Okay, so the first one is the switch. Okay, is the switch. Okay, and the next one, another one is the case. Okay, so this creates a label that execution will switch to depending on the value of the argument. Okay, and we have another one called the break. Okay, the break. So this statement jumps to the end of the switch block. Okay, and we have another one called the default. Okay, the default. This is the label that execution jumps to if and only if it doesn't match up to any other conditions. Okay, so let's say we have a general switch statement, okay, but with an extra label at the end, such as this one here. As you can see, we have the switch keyword, then x is our variable, and then we have inside here the body of our switch statement, and then end of the switch, like this. Okay, so now every break statement will be immediately replaced with this statement right here. Let me show it to you. So let me close this one and I show you. So here it will be replaced with this jump, then end of the switch. Okay, like that. Okay, so but what do we what do the rest of the statements get changed to? Okay, what do the rest of the statements get changed to? Okay, so the case statements can each resolve to any number of arbitrary integer values. Okay, and how do we test for that? Okay, so the answer is that we use a switch table. Okay, and let me show you an example in a C example here. Okay, so here I have a C example. Here, let me show it to you right there. Okay, so here we have our function, our main function. Okay, and we see here some arguments, argc and argv. Okay, you know these ones. Okay, so from there we have our switch statement. Okay, so we have our switch, then our argc. Okay, our argument here, as you can see, our first argument, and then we have our switch, our case statements. Okay, as you can see, case one, we call my function, and then we supply one. We give it one argument, one as the argument, and then we break out of the switch, and then we test for another case. Okay, if argc equals to 2, then we run the code inside this case. Okay, where we supply 2 to my function, and then we do the rest. Okay, like that. Okay, so and when we compile this with CL, we can generate this this listing. Let me show you. So let me show you here. So it's right here, and it's huge. Okay, it's huge, as you can see. I'm scrolling down. Okay, downwards. So as you can see, it's right there. Okay, it ends there, like that. Okay, from here it's very huge. Okay, like that. Okay, so like that, as you can see. Okay, there. Okay, so let's work our way through this. Okay, so first we see that line 10, this one here, line 10 sets up our standard stack frame. Okay, and it also saves ECX. Okay, so as you can see here, we push EX onto the stack, like that. Okay, like that. So why does it save ECX? Okay, so scanning through the function, we never see a corresponding pop ECX. Okay, so if let's take a look. Do you see anywhere where there is push pop ECX? Let's scan. Is there anywhere where there is pop? Are you seeing anywhere where we have pop ECX? There is no. Okay, so as you can see, we have nowhere we can see pop. Okay, so there is no where we can see pop instruction. Okay, pop ECX instruction. Okay, so it seems that the value is never restored at all. Okay, so in fact the compiler isn't saving ECX at all. Okay, but it is instead simply reserving space on the stack. Okay, it's creating a local variable. Okay, so the original C code didn't have any local variable. However, so perhaps the compiler just needed some extra scratch space to store intermediate values. Okay, so why doesn't the compiler execute the more familiar sub ESP4 command to create the local variable? Why? Because we know that in order to create space, we use sub and then ESP and then 4. Okay, so we subtract 4 from ESP. Okay, from the current location where the ESP is pointing to. Okay, command that. Why doesn't it execute that? Okay, so push ECX is just a faster instruction that does the same thing. Okay, and this scratch space is being referenced by a negative offset from EBP. Okay, and TV64 right here, TV64 right here was defined in the beginning, okay, of the listing as having the value -4, as you can see here. Okay, so every call to TV64 EBP as here, okay, as you can see here, TV64 EBP, this one here is a call to this scratch space. Okay, so there are a few things that we need to notice about the function in general. Okay, so first, the label L8 L803 is down here. L803, this one here is the end of the switch label. Okay, therefore every jump shot to this label, okay, like here JA, we have here jump, it's right here. Okay, we have this one here, jump, then you have, okay, let's take a look at this one. Okay, jump, this one here, short, then we have this label. We are looking for our label 03. Okay, where is it? It's right here. Okay, so every jump, as you can see here, jump, short, then this label. Okay, this label. So every jump short, this label statement is a break. Okay, so every jump, every instruction that looks like this is a break. Okay, so this is a verifiable. This is verifiable. Okay, by comparing with the C code. Okay, line by line. Okay, so let's take a look at so here I was talking about this label. Okay, so in first I was not talking about this label L806. Okay, I was talking about this label here. Let's go down this label here. Okay, so label L803, this one here is the end of the switch label. Okay, it's the end of the switch label, and therefore every jump to this label, jump short, which is this one here, jump short, and then our label statement is a break. Okay, and this is verifiable by comparing with the C code line by line. Okay, so label L818, where is it? Let's go down here. This label here contains a list of hard-coded memory addresses, as you can see them right here. Okay, hard-coded memory addresses. Okay, so which here are labels in the code section. Okay, they are labels. Okay, in the code section. Okay, so remember that the labels are resolved to the memory address. Okay, to the memory address of the instruction. Okay, so this must be an important part of our puzzle. Okay, so let's try to solve this puzzle. Okay, so to solve this puzzle we will take an in-depth look at line 11. Okay, so let me just bring that line 11 here so that we don't need to scroll through. So it's right here. Okay, line 11 is right here. Okay, so as you can see here, this sequence performs this pseudo C operation. Okay, so let me bring it here. Okay, let me bring it here so that you can see very well. Okay, so here as you can see, we have if then argc minus 1 is greater than or equals to 4, then we go to our label, which is L810. Okay, which is the default. Okay, and it's right here, label L8. We have this is another label. Okay, so but the label here we are jumping to, it's not here right now. Okay, so as you can see, so but this is the default one, as you can see here. Okay, so here's why this is happening. Okay, so let's have this example here. I show you the setup. Okay, so as you can see here, the value of argc is moved into EAX. Okay, as you can see here, the value of argc is moved into EAX, and the value of EAX is then immediately moved to the scratch space. Okay, as you can see when we use TV64. Okay, like this. Okay, so the value of the scratch space is then moved into ECX. Okay, on this line, as you can see here, is then moved into ECX. Okay, sounds like an awful convoluted way to get the same value into so many different locations, isn't it? But remember, I turned off optimizations. Okay, so the value of ECX is then decremented by 1 on this line. Okay, when we use the sub instruction. Okay, so why didn't the compiler use a dic for decrementing a dic instruction instead? Why instead of using the sub? Okay, why? So perhaps the statement is a general statement. Okay, that in this case just happens to have an argument of 1. Okay, like that. Okay, so we don't know why exactly. All we know is this. Okay, so let me show you. All we know is this as you can see here. EX is the scratch equals to our scratch pad, and then ECX equals to EX, then minus 1. Okay, so finally the last line moves the new decremented value of ECX back into the scratch pad. Okay, so very inefficient. Okay, so let me in the next part we shall no so let's now take a look at the compare and jumps. Okay, let's take a look at the compare and jumps. So let me close all these ones here. Let's now take a look at the compare and jumps. Okay, so let's have this example right here. Let's have it right here. Okay, so the value of the scratch pad is compared with the value 3, as you can see when we use CMP instruction, and if the unassigned value is above 3, okay, which means 4 or more, the execution jumps to our label L810. Okay, and like that. Okay, so how do I know the value, okay, is unassigned? How do I know that? Okay, so I know because JA is an unassigned conditional jump. Okay, this one here, JA is an unassigned conditional jump. So let's look back at the original C code switch. Okay, so let's just close this one and then we'll look back at the original. So it's right here. Okay, as you can see here, it's right here. Switch argc is right here, and our cases. Okay, so remember the scratch pad contains the value argc minus 1. Okay, which means that this condition is only triggered when argc is greater than 4. Okay, so what happens when argc is greater than 4? Okay, so the function goes to the default location. Okay, it goes to the default location, and now let's look at the next 2 lines. Okay, so let's go back. Let me bring it here. It's right here. Okay, it's right here. So EDX gets the value of the scratch pad. Okay, as you can see here, EDX gets the value of the scratch pad, which is argc -1. Okay, and then there is a very there is a very weird jump that takes place. Okay, so as you can see here, execution jumps to a location, okay, pointed to by the value, okay, which is edx times 4 then plus our label L818. Okay, so what is L818? What is that? So we are going to examine that right now. Okay, so let's take a look. Let's first note down that label which I told you. So we have edx, then times 4. Okay, then let's add, then plus dollar sign, then plus dollar sign L81 no dollar sign, then want dollar sign, then 8 like that. Okay, like that. Okay, so we are going to try to examine this one. Okay, so let's bring it right here. Let's bring it right here. Okay, so it's right here. Okay, so it's right here. So L818 is a pointer. This one is a pointer, and it's a pointer in the code section. Okay, so to list it's a pointer, okay, in the code section, okay, to a list, okay, of other code section pointers. Okay, so as you can see here, okay, other code section pointers, as you can see them, L806 and even 807, 808 and 809, like that. Okay, so these pointers are all 32-bit values. Okay, which means dd here, as you can see here, dd is a d word. Okay, it's a d word. So let's look back at our jump statement. Okay, so let's look back at it. It's right here. Okay, it's right here. Okay, so in this jump L818 isn't the offset. Okay, it's the base. Okay, so edx times 4, which is this one, edx times 4 is the offset. Okay, so as we said earlier, edx contains the value of argc -1. Okay, so if argc equals to 1, we jump to this label. Okay, L818. Okay, plus 0. Okay, so which is L806. Okay, so if argc equals to 2, we jump to L818 then plus 4. Okay, which is L807. Okay, so get the picture. Okay, get the picture. So a quick look at the labels, which is L806, L807, L808 and L809 shows us exactly what we expect to see. Okay, so the bodies of the case statements from the original C code above, each one of the case statements calls the function, which is my function. Okay, then breaks and then jumps to the end of the switch block. Okay, I think you get it. Okay, so in the next part we shall take a look at the ternary operator. Okay.